needed. So today what we're going to be talking about are a few things. So our all-in-one, we'll do a little deeper dive on what that's about. There's some apples to apples discussions. We're going to be talking about that. We're trying to make the complex simple. We're going to talk about the apples to apples regarding EMAs as well as hydraulics, selling. We're going to be talking about some power calculations, efficiencies. There's a lot of mistruths going around today, let alone, so we're going to try to just talk about facts and provide data and let you guys soak that up and make your own judgments. Tools, talk about the vector, a little bit about advancements on the Rockwell AOI, and again, reinforce the unique part numbers. And we have an OEM success story focus at the end. And hopefully we can keep this to about that 30 minutes. So industry selling, as you know, this product straddles that line between EMAs and hydraulics. It's a versatile product that is actually accepted in both with no problems. As you know, we started in the EMA world, didn't know much about the hydraulics. We spent many years in the EMA world, and now we're doing both. Again, if you're an EMA and want to get into the hydraulic world, this product is perfect for you, and vice versa. So just keep that in mind when you're out there. We're here to help. We understand a lot about hydraulics and a lot about EMAs, and we're here to help you guys out to hopefully land new customers in those various industries. So going to market with the all-in-one solution, it's to my knowledge, we're pretty much the only company in the world, it's pretty big to say, that are doing this from just a few £100 force to 84,000 pound force. There's a plus sign because you can do multiples of that. Every single product can be an all-in-one. Any voltage, standard voltages, AC or DC, STO, dynamic braking, etc. Our goal is to avoid that finger pointing. Somebody provides the actuator, somebody sized the drive wrong or sized the motor wrong or built the wrong cable incorrectly, and hey, that's not my fault, it's your fault type thing. Our goal is to avoid all that and to provide the one-stop shopping complete solution. So as we quote, we do everything regarding the actuator side. We try to gather as much information as possible. You guys are part of it. We'll do the sides and we'll figure out the torque requirements. We'll figure out the motor. We understand we have all kinds of tools to help us size properly. As we go through the quoting process, if there's a machine issue regarding fit, we'll figure that out as well. As you can see, there's all kinds of different ways with hydraulics. We can stick blocks in to avoid various machines. We can do right angle, inline, even done a 45-degree, all kinds of different capabilities regarding fitting into the machine. We'll select the motor, select the drive for you during the quoting process. Nice thing with this product is that any size motor can be placed onto the actuator. These are the same power unit. You can go really small. You just swap out the motor plates. After the PO is given, we have standard electronic drawings, schematics, all laid out. Everything that's required to run an actuator. When a project comes in, we just remove the items that are not applicable. There's a BOM associated with it. That gets released to production. So everything's standard here. It's not customized. So again, we have our standard schematics, and that helps us streamline things. Drive sourcing is done after the PO. integration, mounting it, etc. to the panel. Harnesses, that's a big thing. We don't make money on the harnesses, but we like to avoid that finger pointing. And we'll make the harnesses as needed. They're standard. We know all the harnesses that are required for our product. We'll source the ones that need to be sourced through the motor, drive, etc. Already designed. We've built many of them. We'll continue. So every harness is built here, tested here, together with a system. Everything's, again, integrated together. Field bus integration, we have all the mappings done. We've done all the popular field buses already, so that's all done behind us. It's all standard. We just select which one, map it together, and we're off and running. Standard program, you select the features that are needed for your application, test it at our facility. We tune the best we can. Obviously, tuning can be done likely in the field, optimize the application. Ownership, there's only one finger pointing to us, so we'll take care of it. We'll take care of the startup, everything's ours. So your application team doesn't have to worry about it. That team can be working on other projects as needed. So we're going to talk about EMAs for a little bit here initially. So a lot of you have seen this slide before and a couple other ones talking about reliability. So in a few slides, it's going to get a little bit clearer why the reliability is dependent on load for EMA, how as load increases, decreases. And for the SHA, it is load independent. As load increases, life does not decrease. I'll talk about this in a little bit. And the same with, you can kind of understand how mechanical actuators need to be oversized, especially when you get into the larger loads, and the cost associated with that is significant. Excuse me, I had to take a drink of water there. So SHA IP advantage, there's some myth truth with this IP. The fine print is important to read. So when somebody says they're an IP67, which doesn't really make much sense to be IP67 and static. You're underwater, you're static. You got to be able to move an actuator. So the EMAs are all rated IP65S, static, IP67, static. That means as you start moving, you're sucking in water. And this is a major problem out there. Same with IP65 with dust, water. It says here in your little fine print, static. So as soon as you start moving, you're sucking in the dust and whatever other particles are out there. That's the EMA world. Ours, IP65M, moving, no problem. Right out of the box, IP65. You can do IP67 with no problem as well. So I want to get into some of the efficiencies and components and system thinking. This gets into that hand-waving people in marketing rooms saying, hey, we're 90% efficient type thing, but what is reality? That's what we want to try to cover here. So we've done a lot of testing. We had to do a lot of testing in the EMA world, and this is how we've done it in our past. Connected up a meter to the input. You have your power watts incoming into your drive and motor. Your drive and motor are in that 90% range. This is pretty much fixed as long as you're in that continuous conduction world. These are very efficient. So knowing that this is your 90 times 90 is your 81%-ish efficient, you can then calculate what your actuator is. You know what the work is being done here. You know the power out. So your power in versus power out. Take out your 80+% there, and you know what your actuator efficiency is. So look at components over here. Roller screws, they keep climbing up in efficiency. Soon they're going to be making energy here soon. Roller screws are 90%, 875 to 90%. They claim 90% is pretty impressive for a roller screw. There's a lot going on there. Ball screws have always been very efficient. Acme screws, not so efficient. You have your bearings, support bearings, timing belts, spur gears. When you add all these up, the efficiencies are significant. Helical gears, preload type mechanisms. Your gearboxes range considerably. There's a lot going on in the gearbox, and in your gear pumps range from 85% to 93%, depending on the type of gearbox or gear pump. So just keep in mind as we go through the next slide or two regarding these components. Each one of these are pretty high numbers. So roller screw, 75 to 90% is what's out there. Again, all those are all on the internet. You can check that. A lot going on in a roller screw. To claim your 90% is pretty impressive. So for sakes of this discussion, we're going to pick 85%, which is still pretty darn high. You can see the spindle. So when people say, hey, the roller screw's 85%, 90%, that's roller screw alone. You got to support the spindle somehow. You see there's a lot going on here. Support the spindle with bearings. Bearings, it's relatively high, 95%. With the nut, if the roller screw's spinning, you get the nut somehow. Also, the nut's tied to a tube. The tube needs to be supported somehow. You have that bushing cartridge type thing, sealing, trying to make it IP54, we'll just say for now. Wipers, etc. I'm leaving off quite a bit. Also, regarding the nut, you got to hold that nut. So as the screw rotates, if you don't hold the nut's going to rotate. So you have to hold the nut somehow, and there's this key in here that has to hold the nut. There's friction there. So you got this anti-rotation mechanism, so the nut's tied to a tube. So it holds the nut from spinning, so the nut can go in and out with the tube. We've selected a pretty aggressive 85% for that. Look at all these guys, add them up, multiply them up. You got 60% for an IP54 mass static, meaning, again, not moving. All metalware items. Now this is reality. This is just basic R&D 101. A lot of people don't like talking about all this because they like just to say, hey, I'm 85, 90% roller screw. And a lot of people, oh, that's incredible. That's amazing. Well, there's cost to everything in this world of design. There's efficiencies that we all have to overcome. If you want to get over the preload, meaning you want to remove the backlash, you want higher precision, there's a cost to that. You got a gearbox, there's a cost to that, significant cost to the gearbox. A lot of EMAs have gearboxes on them. Oh, you want an IP65 or an IP67? Well, there's a cost to that. You have to tighten things up in the front end of this, add wipers, things like that. Again, each step, there's a cost of efficiency. With the Kyntronics SHA, this is based on reality. Every one of ours, we use 70%, and it's relatively conservative, so we're above that. And all our tests have shown that we're above 70%, and that's IP65, which is more efficient than 40% more efficient than the IP65. What does all this mean, this efficiency thing? You're probably familiar with this back in the high school physics days. Work being done over time is your power. Same thing with our actuator. This is a real example. 14-inch stroke, wanting to move back and forth a total cycle of 6 seconds. That means 28 inches total stroke. You want to move 1,500 pounds over 28 inches in 6 seconds. That work being done is 3,500 foot-pounds. Convert that to power, divide that by your time. Foot-pounds per second is 583, and then your ideal power in watts is your 791, and that's ideal. So this is just simple math, but what it shows you down here is that with this converted to your efficiencies, we need 1100 watts, 1.5 horsepower to accomplish that. The roller screw and IP65 equivalent, 50%, you're double the horsepower, which means you're 40% more than the watts. I know I'm throwing a bunch of numbers out at you guys, but this is relatively simple stuff. Just moving an actuator back and forth, you're doing work. Ideal, you apply a percent regarding efficiency, and you know what your watts are, your drive, etc. One example was comparing ours. We quoted 1100 watt solution. It was shared that the competitor picked an 800 watt solution. That obviously is not going to get this solution done. So something had to give. Either they quoted wrong or it's going to fail in the future. It may be less money, but at the end of the day, this is what's going to get the job done with our solution. So the motor's 40% smaller, the drive's smaller, less cost, wiring smaller, less current, etc. Apples to apples. Prior slides, apples to apples regarding power. This is apples to apples regarding what you guys have seen this before, but regarding. So when we quote, a lot of times the application engineer or production person or whoever's involved, this gets kicked up to their boss or procurement. And this is what procurement sees. They see that ours is $8,500 and XYZ $5,300. Of course, just looking at it, for $3,000 more and dismiss us.
Hi, good morning. Is this David?
I don't need help with the website.
Please
Thank you.
mute. Please put yourself on mute, people.
Okay, thanks for your time, sir.
So, again, comparing apples to apples, of course, this is what was $3,000 difference. Makes sense. Okay, well, they'll include the motor, drive, some cables, and the actuator all together. That's not apples to apples either. So, as I mentioned earlier, with the apples to apples comparison, that includes the software, everything wired up, tested. And if you want to include a load cell, again, that's usually included. All we got to do is add the pressure sensor. So the apples to apples selling is important for you guys to help us with this. It's one of the reasons why we're pushing for the quote reviews on every quote that we send out. Review line by line to make sure we're apples to apples to the competition. Make sure that whoever the decision makers are understand what we're delivering, because they're not used to it. We're, again, one of the only companies, or the only company really doing this all-in-one type thing on every single one of our quotes. Of course, if you guys want to provide your own for an OEM, that's not a problem. We work with you on that as well. Your own motor and drive, as we said before. I'm talking about hydraulics, the same type of thing, but it's a little different. Efficiencies are done. You have an HPU, hydraulic power unit, running all day long, motor running all day long. You have the size for losses. A lot of considerations need to go into sizing a hydraulic system. Many times the motors are, just because a lot of times you just don't need to get into all the nitty-gritty details, and just you oversize it 1.5 times, etc. So we're 30 to 40% more efficient than just the horsepower of the motor alone, let alone the thing running all day long. This is an estimate, $800 per year per horsepower at 10% or 10 cents per kilowatt hour. So for a 5 horsepower, again, that's $4,000 that's getting eaten up, and we're a fraction of that because we're power on demand. This is another real example. So for an HPU, we're given the motor on the HPU is 1 horsepower. It's a 1500 PSI unit. You have a 1.5 inch cylinder. They want to do the same 14-inch stroke back and forth, 6 seconds, same type of calculations here. So you look at this and you come back to them and say, hey, that's not real. The 1 horsepower doesn't make sense because this is ideal. You have obviously losses and things in there. So something's amiss regarding these numbers. So especially in it's really easy in hydraulics. Just look at the pressure gauge. If they can send a video, that's perfect. Just looking at the pressure gauge, extend, retract, extend 600 psi, retract 1100 psi, force is area times psi. That's 1,000 pounds, not 1,500 pounds. That's a third less. So that means you need a third less horsepower. So a 33% reduction of pound force leads to that 33% reduction of power. This is an important relationship, just to note. A lot of times we get quotes, and this is an example. The customer may want, hey, I'm doing 1,000 pounds today. I want to go a little bit more. I'm going to add 1,500. You don't realize that you're adding more power, a third more power. And there's obviously a cost of that. And that goes the same with speed. You double the load, you're going to double the power. You double the speed, you're going to double the power. It's just that basic physics thing. Same apples to apples comparison. A cylinder alone to ours is not the same. You add the HPU, of course, that's not the same. The whole system needs to be figured out, designed, valving, losses, control, hoses, connectors, lengths of hoses, routers, all those sort of things need to be done. You have your valves, you have your controller for valves, cabling, supplies, high-end PLC, all that's, it's important to do that apples to apples regarding the quoting as we go through these projects. Of course, there's intangibles, the kilowatts per hour, there's all the leaks you avoid, and everything else that the more controllability you have with our solution. So again, it's the apples to apples theme today of when we're getting into the quotes. So some of the tools, vector update, we're still looking at Q4 beta sites, so think about that. We've shipped a few sales demos, all solution with our software running our alpha versions. We're expecting to do some testing with our new boards here come August, September timeframe and be ready for some beta sites hopefully later in the year, if not Q1 next year. The Allen Bradley AOI is progressing. We're working, sharing the software with Allen Bradley. They're reviewing it. We're working together on that. We're still looking for beta sites. We're also looking for a Q4 release on this project. But if you guys know anybody regarding the AOI, this takes all our standard software, and it's all available. All those features are available in the Allen Bradley PLC. 0 to 10 volt feedback. You don't even need to have to worry about too many crazy feedback devices. You have your position, force controller, everything else available. Again, we're developing the FAQs with Allen Bradley, and we'll send those out as needed. Part numbers, just wanted to reinforce, we said this before, but go out there and quote something. The part numbers are unique. The suffix is unique to that project. So if somebody comes to us with, say, quote me this, we know who did that, and we'll tell them no, somebody else is already in there. So we're protecting you regarding the projects and these quote numbers. There are billions of combinations, so it's unique. An update on our marketing. PowerPoint continues to be updated. Grab that latest or ask your RSM for the PowerPoint itself. New material continues to be added to the website. success stories, quantum piercing, performing horizontal assembly processes were added recently in the past month or two. Leads, we continue to grab leads from the website. Link up to us. Definitely follow us in LinkedIn. We're going to be doing vertical email campaigns. We're going to be talking about that in a little bit. And we'll obviously send you whatever leads we get from our website and activity out there in the web world. So today, there's all kinds of negative things going on in the world. Economy's not all that great. I just wanted to kind of go through some of the things that are active today and to have you guys think about various industries that may be in your back door that may be active and you haven't thought about. You likely have. So obviously today, food, that business, packaging business is cranking. Liquor and wine, people always drink during these type of times. Paper is always used. Canned goods, fitness equipment, home improvements are booming. Lumber, ammunition, you can't keep that stuff on the shelves. Medical, as well as military, is spending a ton of money. So the industry is associated with all that. Packaging, I've heard that packaging had the busiest months ever. 12 months. The flexible packaging over the past 12 months have been incredible. So those packaging industries are doing very well. Extrusion, glass bottling, of course, you can appreciate that. Presses for the ammo, lumber industry, for the home improvement, and obviously the medical military. So we're going to try to do some vertical marketing and work with you guys on some of these. But if you have any of these industries in your backyard, we're here to help you go after these guys. Application-wise, we've talked about a lot of these: presses, testing, clamping, etc. We've done a lot of replacement of hydraulic systems. It's probably our most popular. We're getting more and more into electromechanical, replacing a bunch of electromechanical actuators. Speaking of one, we sent out several different security wedge to the sales channels out there. The EMAs have had a lot of problems, and the security wedge OEMs are looking for an alternative solutions, and we're like a perfect fit. The EMAs are very failure prone. They're sucking in water, they're failing, they're undersized, etc. So this is a very good market for us. Think about your security wedge OEM in your back door. So this is the OEM success story. Just wanted to share with you. This is something that we like to, as an OEM wants, some just may want an actuator. Some want, like this particular one, wanted us to do a little more than just replace the actuator. They had a Parker HPU. It was noisy. It leaked. It was definitely inefficient. Ran all day long. They wanted us to also replace the PLC, and they wanted us to help them increase their control capability. So what do we provide? Provide the all-in-one total solution, one-stop shopping, no finger pointing, better control. We integrated the PLC logic into the code assist. We also developed some preventive codings on the actuator based on the environment. We did all the program management work with them, make sure that we're not missing anything, converting the PLC over and whatever else. This is one of the examples that we actually took a video. We weren't sure, they were not sure of the pressures and system requirements. It changed as it went through. So they took a video of a few strokes. We were able to optimize the solution for them. So again, we'll do all the program management, statements of work, PLC logic, sign-offs, etc. We work with this OEM diligently to make sure everything goes smooth, and we'll do that for any OEM. So just keep that in mind that it's just not an actuator replacement. We can do this system if the OEM is obviously the decent quantities. So in summary, the all-in-one solution, trying to make the complex simple. It's important to think about and talk through the apples to apples, not only the apples to apples regarding the pound force and speeds, try to compare, try to understand what the competition is providing. Versatile offering, meaning you can go either on the left-hand side, the EMAs, or the right-hand side, the hydraulics world. It truly is the most reliable and most efficient actuation solution on the market based on the facts and data. A very cost-effective solution, especially when you're going to be talking apples to apples. And that's the important thing that we're trying to get across. We're seem to be some disconnect regarding the quotes. And now that we're doing the line by lines, we're learning that the apples to apples is really an important aspect of our offering. That's it. You guys have any questions, comments?